All right. Thanks everybody for coming to the session. My name is Ricardo Ferreira, and I'm going to be spend a little bit of time explaining what this OpenTelemetry thing is about and what is the value that you could use for your Go applications. But most importantly, the whole objective of this presentation is to show you how could you actually leverage this technology. And I mean, I think the main purpose is how your code is going to look like if you try to embrace OpenTelemetry in your application. So I've created this presentation as a way for to mimic how do I learn, how do I like to learn things, right? I consider myself a dummy, right? And not in a pejorative term, but the way I learn things is more like a slow motion. I try to focus on the basics and then what is actually important. To then I kind of dig deeper into the complex details that any technology these days have, right? So I try to create a presentation that where somehow be empathetic with probably most people that just like me has the same way to learning. So I'm going to give you this presentation as a 100% end-to-end demo, right? So what I've actually prepared here is I'm going to skip talking about myself because, hey, I'm just Ricardo Ferreira. That's the only thing, and I love Go. You can see that I have a Gopher here on my background besides the cloud. So that's the only thing that's actually matter about me, right? If you want to follow me on Twitter, @RiFerreira, that's my Twitter handle, right? And so that's the whole objective. So what I'm going to do today is to I have a GitHub repository with the whole code that I'm going to show today already available, right? So by the end of the presentation, you can just clone the REPL, fork the REPL, and play the code, right? What I like you to focus on here today is on the details that matter, right? Because the whole code is there, right? If you are in doubt in the end about how to do the code, you can simply copy and paste and then it's going to work, right? But again, I think the whole intention is for you to see what actually matters. Because here's the thing about, in my experience with OpenTelemetry, right? There is a lot of moving parts, right? That's my overall conclusion about working with telemetry. And if you jump straight to the technology and you don't fully comprehend what actually matters and the basics, you're going to end up really confused. At least that's how I ended up, right? So that's what I'm trying to avoid here today. Before we jump straight to the code part itself, right? I would like to at least, right? This is going to be probably the only slide that I'm going to use today. So I would like to keep everybody in the same page about some terminologies that are common on the OpenTelemetry world, right? So those are, first of all, you have this concept of backends. What are backends? Backends are going to be those fancy. Some of them are product-driven, some of them are open source, some of them are proprietary, but there are going to be backends that you are going to use to monitor and observe, right, your applications, right? So there's a bunch of them out there, and we're not going to discuss anyone in specific, right? What matters for you is that OpenTelemetry, it is an open standard, right? You can write code in OpenTelemetry, and it's going to work with pretty much all the backends that is available out there. And the backend is going to be where your telemetry data is going to be stored, right? That's it, right? Think about in the backend as your database, right? For now. And then there are two ways for your applications to send data to the backend. There is the direct approach, which is what we're going to use today for time constraints, because we only have 30 minutes for this presentation. If actually we have time, right, I'm going to show the other approach. But the first one is your applications can send telemetry data directly to the backend, right? There's one condition for this to happen. The backend needs to support OpenTelemetry, and more importantly, to support the protocols that are available on the OpenTelemetry standard, right? There is one called OTLP, right, which is the standard protocol for OpenTelemetry, right? So that's a first, right? Make sure your backend supports that. If for some reason your backend does not support the OpenTelemetry standards, you can use something as called a collector, right? A collector is this component over here that's going to act like your, let's call middleman, right? So your application send the telemetry data to the collector, and then the collector is going to be responsible to talk the specific protocol that the backend supports. That perhaps is not OTLP. It might be something like, I don't know, REST or Kafka or gRPC, or some other protocol that some of them are really very creative in building them. But the point is, there's two approaches for you to send telemetry data to the backend, right? Using the collector, if perhaps the backend does not support OTLP, or if the backend supports OTLP, just go straight to them, right? There's actually a third situation where using the collector might be a good idea, even though your backend supports OTLP. But let's discuss this on the end during the Q&A, right? There is a very particular situation that has to do with performance sizing, right? I can explain this later, right? All right, and keep in mind that today, right, May 2021, OpenTelemetry supports traces and metrics. Those work, right? The support for logs is on the roadmap. It's being implemented. There's a bunch of POCs that are being used out there. There's a lot of open source technologies being included in the project for trying them out, right? But the reality is that logs are not supported today in OpenTelemetry, right? I think highlighting this is important because I've seen some people in the community that are eager to jump straight to OpenTelemetry applications, but it is part of their observability strategies to include logs as well. So keep that in mind, okay? All right. As I mentioned before, we're going to use an example to teach whatever we need to teach it here. So let's go to it. So I'm going to actually put here the URL of this GitHub repository. Let me copy it first. And I'm going to put here on the comments. As a matter of fact, I'm going to put here on the private chat, and if my friends from the backstage could help me copy this to the main page, I would appreciate it. Okay. Here we go. All right. So it's going to be copied. And what I have here is I've already closed this. I've already closed the, I've already cloned the REPL, right? In my machine here. And keep that in mind that this REPL, right? I'm going to open here one more time. Let me put this window over here so you can see it. Okay, no, this is not what I wanted to do. All right, just give me a minute here. Tab window. Here we go. Okay. This is what I wanted. All right. Having some confusion here what it means. There is the code, right? The GitHub repository is going to be passed on the link. And there is a branch that I'm using here that I've called demo, right? What is the difference between the demo branch and the master branch? The master branch has the whole code ready to go. Just clone it, use it, right? I'm using here the demo branch, all right? Why? Because it is a code that is incomplete intentionally, right? So I'm going to build everything from scratch. So that's the whole difference of the code. All right, so what is the other one? Here we go. Okay. Let me put this window over here. It's going to be more awesome. Actually, this is my main branch. I'm sorry. Let me close this guy over here. Let me open it here by using the terminal because somehow I've missed my window. Put this on my temp folder and should be a folder here called GopherCon. Yep. Code hotel Golang. Yes, it's supposed to be this one over here. Right. So here is what we are going to use today. And so everything is a simple hello world, right? So I'm going to actually demonstrate here real quick. So if I curl this, you're going to see that you see here, it's a simple hello world application that doesn't do much other than responding hello world. And my backend is already up and running in the backend. So what we are going to do here right now is actually using this backend. So let me put this window over here. My windows are misbehaving today. So for some reason, not all of them are being shown here. Here we go. So this is my backend that I will be using today. And this is called the Elastic APM, but as I mentioned before, you can use whatever you want. Right. Now I think my window story is fixed. So as you can see here in my observability platform, there's nothing going on. So just even though I actually call the microservice now 3 times, right? My window is not being shown anything, right? So what needs to happen is that every time I call this API or REST API, an entry is shown there on my observability. So let's do this using our observability code. So let's do this actually, because for some reason my windows are not. Let me put everything down for a second, right? And I will close this window over here. Just give me a second, guys. Okay, I'm going to quit this guy over here, and then I'm going to open another one. Yes, thank you, finally. All right, so I'm going to use actually my master branch over here because I don't want to waste too much time with window management. And okay, this is the one that has the master branch, presumably. All right, yes, this is the master branch. Okay, all right, so let's do this. Sorry for the confusion because I'm a new Mac user. I used to work with ThinkPad that was gone last week. So I'm starting to get used with this whole Mac experience, and windowing management is, I'm terrible at it. So bear with me for a second. So this is the code to catch up with time. This is the code that has everything. So I'm going to do things differently. Instead of actually creating all the code on demand, I'm going to simply run this. Actually, probably is going to be a very nicer experience than I was planning before. But I'm going to run this with everything up and running, and then I'm going to simply explain the code that I was planning and to put it like gradually. So let me open up everything. The code that you were looking here, as you can see, it has. All right, let me put this over here. You have 2 options of running with this. Without the collector, which is the option I'm going to use right now, and with the collector. The basic difference between 2 of them is that if you look at without collector, you're going to see that our microservice sends the endpoint directly to the APM server, as you can see here, right? So with the collector, you're going to see that our application, hello application, points to the collector, and the collector is configured to actually talk to the APM server. So remember, I've mentioned before about the middleware. So that's what we were trying to think before. All right, cool. So let me start things up over here. Don't want to actually spend too much time on this. Let me force here a build because the other code was using the branch that was a demo with incomplete code. So this one is going to run all the code with everything up and running. So what we need to see here, let me explain the demo. You're going to see that every time I call the REST API, 2 things are going to happen. Actually, 3 things are going to happen. The first one, every call will create traces, right? almost like a one-on-one relationship. Every single call is going to create a tracer, right? It's not very prudent to do this in production in a real world. I will explain why later, right? But for demonstration purposes, that's what I did, right? Secondly, there are two metrics that I've wrote the code for it. One of them is updated manually. Every time the API call executes, the code go there to the metric and then increment a value, right? So that's why I call it updated manually. And there's another one that I've created intentionally to demonstrate the power of OpenTelemetry to create like automatic metrics, right? So you simply write a callback function and go, and then you provide to this, let's call data structure for OpenTelemetry, and then it's going to be periodically updated itself, giving a periodicity that you configure, right? So let me see if everything is up and running. It seems to, at least. So let's just refresh here. At least one thing that I've already learned about Mac, you have to press Command R to reload. So that's the thing you have to keep in mind, right? So let's check if the APM is running. So here we go. All right. So as you can see here, we have some. Let me increase a little bit the font size. Probably is going to be a little small for most of you. All right. So as you can see here, my APM platform already has the representation of my Reload app, and presumably my Reload app should be running as well, right? So if I call it here, hello world, so it's working as expected. What needs to happen is that I'm going to click here on Hello app, and there is one transaction that is already detected here that was created using OpenTelemetry and then sent to the backend platform called hello, right? And then this transaction, let me filter here for the last, 5 minutes. This transaction probably has been executed multiple times because, right, if you look here on my, without collector, if you look here on my Docker Compose, I have configured a health check here for 5 seconds. So every 5 seconds, there is a curl command that executes and invokes the API. So that's why it's keep being executed continuously. And the most important part is that here we go. Those are the traces that were created using the OpenTelemetry code. And that's the part I would like to spend some time explaining how it works. But for the sake of understanding of what we have here, this timeline here has this /hello. Let's call this the main transaction or the business transaction per se. This is the naming convention that the industry uses. A business transaction is broken down into multiple technical transactions or spans, as they call. So there's one called build response, responsible for build response. And there's another one called my span, which is an example that I've created to how to create a custom span programmatically, right? But what you need to understand here on this timeline is that both my span and build response are executed within the context of the main transaction, all right? So there is a correlation between them, okay? Now let's see how I created this main transaction over here in the code, okay? All right, so let's talk about the code itself. So let me control, I think I can increase the font size over here like this. Yes, this is how I increase the font size. Okay. All right. So the code itself, if I jump straight to the bottom of the code, I'm basically using I'm registering this function here, hello, right, as you can see here, and then I handle a request and response. And basically, forget about the code of OpenTelemetry for a second. Pretty much what I do is to build a response. I'm providing the writer, and then the build response essentially set 200 in the HTTP code, set the content type to JSON, and then marshal the hello world response to the payload. Pretty much that's what I'm doing right here. And then I've created a callback function is valid that always return true, but just for the sake of demonstration, right? This is essentially what the code does. But in order to create the transactions, you need to do a couple things, right? The first one Remember that in the run without collector, in the application, we provided this exporter endpoint, right? That's the first. You need to provide the endpoint about where is your collector or where is your APM server to your applications. Once you have this, I call it exporter endpoint, but it could be anything, right? Once you do this, the first thing you do is to retrieve your context, right? And then you're going to grab this endpoint and create what we call a driver, right? A driver, as the name implies, is the protocol that's going to be used to transmit telemetry data. It doesn't necessarily have to be OTLP gRPC, all right? That's the standard, right? That's OpenTelemetry 101. You're going to probably start with OTLP, which is a gRPC implementation, right? But you can use other protocols that are supported in the OpenTelemetry world, like Zipkin or Jaeger. There's support for Kafka. So there's a bunch of other drivers that you can use. I've choose to use what is the standard here, right? Once you create a driver, you're going to create an OTLP exporter and simply provide the context and the driver. All right, simple as this. I have an exporter, all right? So my application now have a way to send the data first. Cool. And then you are going to, you see that my application is called Hello App here. If you go to the APM tab, it does have a name, right? Where this name came from, because I create what we call resources and attributes, right? So the service name is a constant that I've created that points to Hello App. So that's essentially what I did. So once you create a resource, right? This is an optional object. You don't need to create it if you don't want it, right? But it is a best practice to name your things, right? Otherwise, it would appear here on the back end some weird auto-generated name that nobody would have a clue about what that is, right? Once you create your exporter and your resource, you can create what we call a span processor, right? What is a span processor? Everything in Tracy's word is spans, right? So what is a span? This is a span. Let me give you an example of a span. A span is one of those lags here of your transaction. So you need a processor to process all of them. And I've chose to use a one that is able to batch, right? Instead of creating one network connection to every single trace or every single span, they're going to be batched and then flush it periodically all at once, right? It's faster, and programmatically speaking is like a better practice to use this. And then you can specify the resource, what span processor, which is the batch processor, and you are going to create a tracer provider. This is my provider. This is something that's going to be made available within your whole application, right? Why you need a tracer provider? Because there will be traces and metrics created by you, right? And there will be other traces and metrics created by external libraries or frameworks, such as you can see here, I am using here, where he is, I'm using here the MUX Framework, right? Which is essentially a framework for HTTP and REST API. So pretty much what I'm doing, the MUX frameworks they have a middleware that can wrap all your functions and REST API calls. But in this wrapping process, right, they're being like an instrument to create traces and metrics, and how they are going to actually leverage what you created, right, programmatically. You have to register what we call, where he is, a tracer provider. So it is your responsibility to create a tracer provider, okay? Okay, I'm going to skip this right now because this has to do with metrics. I'm going to jump. So if you are not intending to create metrics, you don't need this here, the pusher, as we call it. So I'm going to jump for a second. And then finally, look what I'm doing here. I'm going to use this package OTel and register globally in my application my tracer provider. So let's recap. How you create a tracer provider? You create an export, you create a resource, and you create a batch span processor. You blended everything together and create your tracer provider out of them, okay? And then you have to make the tracer provider available within your applications, right? And then I've optionally, you don't need to do this, but I have optionally used a TextMap Propagator. A TextMap Propagator is something that if you were using frameworks that are non-blocking or asynchronous, or perhaps your architecture has layers running on different threads or processes, such as, for example, Kafka, which is a producer and consumers that are running on different threads, you are probably going to need a TextMap propagator to propagate the context asynchronously, right? If you just register them, this is almost going to happen automatically. There's a little piece of code you need to write, but pretty much it's going to be handled for you automatically, right? Okay. And then forget about the meter for a second. Let's focus on the tracer first, right? And then the tracer is the object that you are going to actually create to instantiate your own spans, right? Now, let me explain this because it's not very intuitive. And after all, we are in a for Dummies presentation, right? So we need to focus on what's not clear at first. If we go back here to this transaction, you're going to see that this main transaction here, this /hello, it's even on the bolded fashion. This one was created not by me. I didn't write the code for create this one. Who created this one was where is the line here? Was this middleware over here, right? So if you don't do anything and your job is essentially to register the tracer provider globally, all the other frameworks that are compatible with OpenTelemetry, and if they have middlewares, right, they're going to be able to create traces for you, just like I did here. Another example, let's say your application read and write data into Redis database, and you are using a Redis framework that is compatible with OpenTelemetry. So all the traces regarding your interaction with Redis would show up there automatically. You don't need to write code for this. If the frameworks are, number one, compatible with OpenTelemetry, number two, they are registered as middlewares, right? However, as you can see here, I've created this build response trace myself, right? Intentionally, to demonstrate how you can programmatically create your own traces, okay? How did I do this? Let's check it out. So in my callback hello function here that I've registered, here is my invocation to the build response function, right? This is the code that you would have regardless. It will be sitting there in your code. What you need to do is to wrap that invocation with a span, right? So how you create a span? You basically create a tracer, right? And then you call the method start. You have to provide the context. Everything in the Go word, you know better than me, has to do with the context. If you don't provide a context, or if you don't provide a context that's not up to date, right? This correlation here on the back end won't occur, or probably will be completely messed up, right? So keep in mind of keeping track the updated context, right? In my case here, the context I retrieved from my request object. So for other further down calls, starting from here, you have to keep providing the context, right? And then you give a name. I call it build response for the sake of simplicity, right? And then you are going to do this. And by the end of the invocation, you have to end your span, right? Why is it important to end your span? Because if you click here, you see this build response took 8 microseconds to execute. So this time here, right, was basically calculated because by the time you create a span and you end the span. So OpenTelemetry keeps a tab of this execution, right? And it also includes some other metadata that is useful for troubleshooting purposes. And you can optionally, in your code, also decorate with some other labels, perhaps providing some contextual information about the code, right? And then I have this other my span over here that was created the same way. I've created a custom span that I've created my span. I've executed the isValid invocation, and then I finished my span. So as you can see here, both this span and this span was executed within the context of hello. And it is your responsibility as a developer to mimic this behavior. So whoever is on the back end, remember, the people that are on the back end, they're likely, they can be, but they're likely not the same people that actually wrote the code for the microservices or applications, right? So they won't understand by first how your flow works. So it is your job to make your transactions observable, right? So what you see is what you get, right? So basically what you're seeing here is how the code is behaving, right? So this is how you should handle your invocations. Now, all right, so this is how you create both automatically and programmatically spans or traces, right? Spans and traces, most of the time, they can be used interchangeably, all right? However, let's talk about metrics now. So if I go here on my backend, which is Elastic, right? If I go to discover option, there is this index, right? That is basically focused on metrics, right? I'm going to actually filter here to only show the number of invocation metrics, right? So those are documents that has been indexed, and they contain a metric called number of executions. So let me open one of those documents over here for a second. And you are going to see that, here you go. There is this metric called custom metric number of exec, and the count is currently 178, right? So it's counting. Remember, every time the REST API call is executed, the metric is incremented manually, right? So how did I create this? So let's see this part of the code. First of all, this is the increment being occurring. So basically, I've called number of execution, and then you call the function add, passing the context, that's important, and then you increase by 1. 1, 2, 3, 4. It's a stateful object, so it maintains the state, right? So how did I create this object? That's the important part. So first of all, you have to create the part that I've, where is the part that I've, here we go. You have to create by yourself something called a pusher. I don't need to explain much about what a pusher does. They push metrics. They run in the background and they keep pushing all the metrics that have been accumulated within your heap memory, and they push to whatever exporter has been defined. So basically what you have to do is to create, you define a distribution for the exporter, and then you can reuse the same resource and exporter that you have used it for your traces. Most of the time, they will be the same, unless you are sending your traces to one backend and your metrics to another. Possible, but it doesn't make any sense. But all right, you get the point. And then I've specified here that it's going to push every 5 seconds, right? Right. If they're going to push every 5 seconds, and then you start the pusher, and then eventually you need to stop them. So I've deferred here the stop of the pusher to the end of the microservice. So when you stop the application.
Great.
Once you have a pusher,
we've really run out of time, unfortunately. Is there anything you just want to say just to tidy up this loose end?
Yes. No. Basically, what I would like to wrap it up here is the creation of metric. But I've mentioned before, you can simply use the look the code. It's kind of simple the way I wrote. So just follow up there, and I'm available for questions if there's some time. If not, that's okay. I understand. But yeah, I think thank you, organizer, for having me today, and I hope I have explained how this whole OpenTelemetry thing works.
You really have, actually. It was great to see that in action, and you know, live coding, it always gets extra points. So thank you so much. I think you, after the next talk, if you can hang around,
yes,
in speaker room 1.
Yes,
that's where people can.
Yes, I will.